All right. Hello and welcome to our Navigating Energy Star's Unique Requirements webinar. I'm Sean, this is Luis, and today we are going to be talking about Energy Star and some of the specific niche requirements that you have to hit in order to be eligible for the Energy Star certification, as well as the 45L tax credit. So we are assuming that you have at least some baseline knowledge of either Energy Star or the HERS rating process, since those two overlap quite a bit. But we're going to kind of just dig into this. So my name's Sean Revel. I am Layton's 45L tax consultant. I have been doing HERS ratings with a primary focus on Energy Star and Zero Energy Ready Home certifications for the last 5 years. I have helped clients claim millions in 45L tax credits here at Layton. And yeah, I'll let Luis introduce himself.
Yeah, so my name is Luis Aguilar. I'm the professional engineer here at Layton. My PE is in HVAC and refrigeration, so very much related to some of the requirements that are necessary to qualify for Energy Star in multifamily as well as a single family. So a little bit of my background. So I work extensively as an energy modeler for 179D, which is the energy efficient commercial building deduction. So a little bit related to this, as we'll see later on in the PowerPoint, delivered probably millions of deductions as a modeler, and now doing certifications and doing field inspections for Layton as a professional engineer for the 179D department. So it's a little bit about myself.
Great. So if you're not familiar with Layton, we are an international tax consulting firm that specializes in niche technical tax credits. We have over 50,000 clients, 3,000 employees. We are international, so we're in multiple countries, and we have over 25 years of experience in helping clients get tax credits. So why work with Layton? Why are we talking about Energy Star? The whole purpose of this is to get the 45L energy efficient home tax credit, which the value of that can range from $500 per unit up to $5,000 per unit, depending on building type, prevailing wage requirements, and what certification you're pursuing. So today's talk is specifically about Energy Star, which multifamily projects that are not paying prevailing wage, if you get Energy Star certification, it's $500 per unit. If it's single family, there is no prevailing wage requirements, and it would be $2,500 per unit. And Layton is an Energy Star rating partner, so we are able to do the full certification process for our clients, as well as consult with them on how to achieve Energy Star compliance and get those tax credits. So this is just a kind of quick review where things stand with Energy Star as of right now. Currently in 2024, Energy Star Single Family New Homes version 3.1 is required to be eligible to receive that $2,500 per unit 45L tax credit. Usually with Energy Star, states are allowed to select which version they want to adopt on their own timelines. However, to achieve the 45L tax credit, it is written in the IRS guidance that starting in 2025, for all buildings completed January 1st, 2025 or later, they have to be compliant with Energy Star version 3.2. The big difference between Energy Star version 3.1 and 3.2 is 3.1 is based on 2012 IECC, where 3.2 is based on 2021 IECC. So significantly about 10% increase in the overall insulation requirements for 3.2 versus 3.1. So about 10 points lower on a target HERS score for the ERI pathway of Energy Star single family. Energy Star new construction for multifamily is on version 1.1. As far as we know, for the foreseeable future, Energy Star version 1.1 for multifamily will remain the same. It's based on 2012 IACC, so somewhat compared to the single family home requirements, a little bit more lax on the insulation requirements, but it has a lot more technical requirements, in particular with HVAC, which Luis will be talking about later on in this presentation. So this is just kind of an overall overview of the process for getting Energy Star certified. As you can see, the single and multifamily programs have a similar, very similar requirements with some slight differences. For example, multifamily has some different pathway options. So you could do a prescriptive pathway, an ASHRAE modeling one, or an ERI, which is Energy Rating Index pathway, where single family is strictly just the ERI energy modeling pathways available. There's, as I mentioned, much more emphasis on the design, in particular of the HVAC, on multifamily programs, where there's some more options there for the single family. They both all have the same requirements for inspections. Theirs has to be a pre-drywall inspections, as well as a final test out with blower door and that sort of thing. So, meeting modeling requirements. This is in particular just material changes that I've noticed after doing a lot of modeling that have the biggest impact overall on meeting Energy Star energy modeling requirements. The big one always is continuous exterior insulation. Always has a very large impact in that it essentially eliminates the framing fraction that you get from studs in the wall. It prevents thermal bridging and usually has a very big impact. It also allows you to bypass some of the Energy Star framing requirements if you're doing continuous exterior insulation. So if you can fit it into your budget, using ZIP-R paneling or just any sort of exterior, foam board rigid insulation has a very big impact on the overall energy model. As I mentioned before, framing is essential. So in a typical, 2x6, 16 on center wall, the wood studs reduce your overall R value by about 20-ish%. So that's when I'm talking about framing fraction, that's what I'm specifically talking about. Using advanced framing techniques, which if you're not using continuous exterior insulation is a requirement by Energy Star, can reduce that by, get that number down to 16% framing fraction. Another thing that I always recommend is windows have a big impact on the overall energy model. A 0.3U window is basically equivalent to R3 compared to in most northern climates, you have to get up to at least R20 in the walls nowadays. So the amount of actual window space that you have has a very outsized impact on the overall performance of the energy model. I always recommend it's cheaper to reduce the amount of glass that you have than it is to upgrade windows to triple pane or something like that. I always recommend blown-in fiberglass insulation to my clients versus bats if those are what you're in between. Blown-in can get you a higher R value. It also makes it easier to meet grade 1 insulation performance, which we'll kind of talk about later. ERVs or HRVs, energy recovery ventilation or heat recovery ventilation, help the model a lot. They also help a lot with indoor air quality, especially in wildfire prone areas. And the big thing right now is heat pump water heaters have a huge impact on energy modeling. I can see it usually dropping your HERS score by about 7 to 10 points. So it has a huge impact on models. And there are a lot of rebates out there right now for them specifically. So it makes it a pretty low cost choice with helping to hit your target score requirements to meet Energy Star. All right, slab edge. This is the #1 failure point I see on projects for why they do not meet Energy Star. Energy Star requires in climate zones 4 and above that you have to have slab edge on between all conditioned slabs and unconditioned slabs that are on grade. If you want to take a look at the picture on the left, that's a picture of good slab edge insulation. It's not going down the 4 feet horizontally that's normally required because it's in contact with under slab insulation. So there's an exception there that you don't have to go the full 4 feet down. If you're doing under slab, it can help you potentially save on material costs. But that's an example of good grade 1 slab edge insulation. On the right, we have is poor slab edge insulation, mainly because the walls are not aligned with the slab very well there, and that it's uninsulated because it's between a garage and a living space. For Energy Star purposes, garages are always considered unconditioned space. Even if for some reason you are heating them, it's still considered unconditioned, and therefore you have to put some slab edge insulation between the garage slab and the conditioned space slab. Similarly, this goes for any patios and porches, and this is a requirement on multifamily as well as single family. So if you have a continuous, a gypcrete poured slab going from inside a building out to a porch on the second, third story building, you still need to put some sort of thermal break between the exterior porch and the interior living space. It also applies for garages. If you have any garage space underneath it, you need to have a slab edge between the living slab or the conditioned slab and the garage space. Similarly, for climate zones 4 and above, you also need to insulate the floor on multifamily buildings between that garage space and the conditioned living space. Drywall gasketing. So probably a term not a lot of people are familiar with. I put in the exact quote from the Energy Star Radar checklist that it references. Essentially what it means is you have to, using something that is not construction adhesive, seal the drywall to the top plate. Now, this is a prescriptive requirement for Energy Star, but it also helps with you hitting your blower door targets that you do come to when you're modeling initially. Usually sealing the top plates can reduce the total air leakage of your home by about 20%. So it can make a huge difference and help a lot. There is a product by Great Stuff specifically called drywall gasketing. So you can put, it basically works as weather stripping for the drywall. You can put it up on the top plates before you hang the drywall and then just drill into it, creates a nice seal. If you have a large unconditioned attic, you can always go into the attic space and seal it from the top down. This was an example that I did for a friend of mine who needed to pass a blower door test, and we went in after he'd already insulated, which makes it a lot harder, but still spray foamed all the top plates and were able to help him pass. All right, ventilation. So you have to meet ASHRAE 62.2-2010 or later and for each dwelling unit on a project. The 62.2 requirements must be met after install, so it's very important to take into account line loss and static pressure when you're designing your system to meet the 62.2 requirements. Bath fans must also pull at least 50 CFM, and kitchen fans must pull at least 100 CFM. There are a couple of niche alternatives for that if you're using continuous running fans or something like that, but that's generally the requirement, and that is all what it has to be at final test out. So what that really means is if you're installing a 50 CFM bath fan, once you take into account line loss and that sort of thing, usually it's actually pulling about 38 CFM, in which case you would not meet that Energy Star requirement. So in that case, I always recommend is install an 80 CFM bath fan. Usually once you have the line loss in there, it's closer to 50 CFM. and then you can pass that 50 CFM requirement. There is a plus or minus 15% wiggle room depending on altitude and some of those, like if the air's thinner in certain areas. There are some exceptions for that, but those are generally the requirements. And if you are using a bath fan to meet 62.2 requirements, then that bath fan must be ENERGY STAR certified. All right, grade 1 insulation. So same project, vastly different insulation installs here. On the left is a grade 1 install. So it has minimum gaps or compressions. It will have all 6 sides of encapsulation. That's a very important thing with ENERGY STAR, is that 6 sides of encapsulation. So in this case, the 6 sides of encapsulation are top plate, bottom plate, left stud, right stud, then OSB sheathing, and then drywall, once it comes in, will fully encapsulate it. 6 sides of encapsulations is a requirement to meet what is considered grade 1 insulation, no matter what. If you want to see what is not grade 1 insulation, if you look at the right, there's lots of compressions, which prevents that insulation from making contact with the drywall, which would prevent these 6 sides of encapsulation. It's also jammed behind the outlet, which is a no-no. You're supposed to cut out around outlets. And yeah, it applies as well for any spaces behind tubs is a commonly missed spot, or bump outs in the wall for plumbing or mechanical ducting. You have to make sure that if you're using fiberglass insulation, it is in contact with an air barrier on all 6 sides. Spray foam is its own air barrier. And to be considered grade 1 for spray foam, it has to do with more how the spray foam's installed. There can't be more than a 1/4 inch of variance in height. Once again, minimal gaps, minimal breaks in the insulation install. So advanced framing. So this, by using, if you use SIPs, structurally insulated panels, or continuous exterior insulation, you can avoid having to meet these framing requirements, because you're breaking the thermal, you're preventing the thermal breaks of the studs by using SIPs or continuous exterior insulation. So the advanced framing that's required is minimum R6 in corners. Really what that means is you need to be doing California corners so you can get the insulation all the way into there. Wall intersections, where interior walls meet the exterior walls, you have to leave a space in there to be able to insulate behind it. The trickiest one, and where, a lot of builders aren't used to doing it, is you have to insulate headers if you are not using continuous exterior insulation of some sort. It needs, for 2x4 framing, it has to be at least R3. For 2x6 framing, it has to be at least R5. And that's above all windows and doors. It is a prescriptive requirement. There is not a way around it. However, there's also a requirement on the single family program, which isn't in here, to have just 1 jack and 1 king stud for windows, to just reduce the overall amount of wood in the framing systems. That is not a requirement for the multifamily program. And then for climate zone 4 and up, you should have at least R20 insulation in the walls. So you have to be using high density bats, or blown in insulation, dense packed, or some sort of spray foam at that point to achieve the R20 minimum that's required.
Okay. Cool. Thank you, Sean. Yeah, so I know Sean went over a lot of the requirements that are more so, like we said, for a single home as well as multifamily as well. So just to remind you guys, here's kind of what the process looks like. And I'll be going more into the multifamily new home certification process. So as a part of the requirements, in order for you to pursue Energy Star and be able to attempt and see if you qualify for it, there is some qualified individuals that must be a part of your process, essentially. So two of those being the ASHRAE Path modelers. Sorry, did I hear some? Did anybody have a question? I heard a background noise. Oh, okay. If you guys have a question, just feel free to add it to the Q&A text and be happy to answer. But moving on, as I stated, the ASHRAE Path modelers is one of the paths that we can take to qualify for multifamily Energy Star. And in addition, we have the functional testing agents as well. So these are qualified individuals who could go into the home, in this case being a multifamily system of units, and ensure that the requirements are being met. So that's kind of where I come in, and I'll talk a little bit more about that, as well as the third, which is the building stage, which is where these requirements must be met and where we check to ensure that they're taking place. All right, so as I stated, the functional testing agent, who are they? Who can check to make sure that things are operating how they're supposed to do, and verifying the requirements are met. So one of the requirements is to be a licensed professional mechanical engineer, such as myself. And so that's why I qualified to be a functional testing agent. However, that's not the only requirement. Here's a list of additional qualifications that would allow you to become a functional testing agent and go on sites and verify and do this testing yourself. So here's just a few. I will say the list here is individuals who can fill out the entire portion of the functional testing. There is additional qualifications which can fill out, very specific portions of the checklist, but these are the ones that can complete the entirety of the checklist and can do that for you and ensure that you're meeting the requirements for multifamily Energy Star. All right, so as we spoke, there's 3 different paths that we can take towards qualification of Energy Star. So one being the prescriptive path, which is a little bit different and it's not going to be available in California. So for those of you that are located in California, this is not an option for you guys. And then we also have the ERI path, which is very similar to what Sean already does for single family as well. So we have experience doing that here in Layton as well. And then the third being ASHRAE path. So this is when you utilize an energy modeling software and you compare it versus an ASHRAE standard. So this is my personal favorite in my opinion, and what I would suggest for any clients that would like to do a certification with Layton, as we already have a team of ASHRAE Path modelers in-house who are qualified and are very familiar with utilizing energy modeling software because they already do so for an additional, for 179D, a deduction that we are experts in, and then as well as myself, right, being a functional testing agent and already having experience with 179D. This is something that I think the ASHRAE path is what I would recommend for anyone that chooses Layton to move forward with Energy Star certification. All right. So the certification process itself. So just like Sean discussed with a little bit more about the installation requirements, the multifamily itself is going to have a lot of testing requirements that must be done by the functional testing agent myself. And there's a lot of overlap between multifamily and single family. So I'll be discussing the first 4 here. The last 5 being the VRF outdoor units, boilers, cooling towers, and chillers. That's going to be only for multifamily, and the testing for that's required is only for multifamily. We won't be discussing those just due to save time and because it doesn't overlap with single family as much. But just so you know, there is requirements for those as well. Just want to make sure that that is noted. So before myself as a functional testing agent can go on site and take a look at this, there is a few things that I would need before going on site, and one of those is the HVAC design report. So a lot of Energy Star compliance is making sure that things are operating how they're intended to operate, essentially, right? It's very important to ensure that an engineer has designed a certain property to operate at a certain amount of efficiency. However, we know that's not always the case on site, and when we go and test the equipment, it's not operating how it's supposed to be. And so that is what the HVAC design report is going to do for functional testing agents. We're going to be able to refer to that, and that's pretty much going to be our guide to ensure that we're within the design ranges. There's a certain percentage that we'll be looking at, but just to give you an overview, that's the HVAC design report is going to be key here. And just an additional things to consider. So we consider all the HVAC systems in the building that serve dwelling units, common spaces, parking garages, but may exclude systems solely serving commercial retail spaces. In terms of the units that we test. And so, yeah, let's take a look at it. So here's an example of the HVAC design report itself. So here's just the first page and what it looks like. It's a multiple page document that we take a look at. And some of the things that are on this page is going to be, some of the loads for the rooms, for sensible load for each room, latent load for each room, the specifications for the AC unit itself. So we're looking at design airflow at maximum speed. If it's a multi-speed, we have the low, medium, high speeds, as well as design airflows for each zone. So each home could have multiple different zones, those being, the bedroom, dining room, living room, things of that nature. So there's a specific amount of airflow that must go to each room. So we want to make sure that we're taking a look at all this and familiarizing ourselves with how it's intended to operate before we go on site. All right. So the refrigerant charge. So this is one of the overlapping things that are checked for single family as well as multifamily. And that's one of the checks that we do on site to ensure that AC unit is conditioning how it's supposed to condition. So I always like to bring up the story of having an AC tech come over, and one of the things that they always suggest is that you need more refrigerant, and they add refrigerant to your unit, and then everything's working again, right? The AC feels cool again, and then you can get back to doing what you're doing. So it's a very common issue, as you can imagine. If you don't have sufficient refrigerant, what happens? It could lead to a lot of different issues. You can have, freezing coils, which is horrible. And then in addition to having that, you have a system that's running all day, trying to meet the set point and trying to cool your house. So that's a lot of electricity that's being wasted. So Energy Star definitely prioritizes that. So part of the checklist, we're going to be taking some measurements. Here's a few of the measurements. There's definitely a lot more, but the purpose of taking some of these, so for example, the liquid line pressure, the liquid line temperature, and the same for the suction line, is that we want to get a measurement of the subcooling and the superheating of your AC system. So what does that mean? So essentially, if you have too much superheating, which means that you're taking in too much heat in your evaporator coil, what can happen is that could be a symptom of not having sufficient pressure in your system. So typically for medium temperature systems, like the ones that we see in homes, we're going to see anywhere from 50 to 220 psi pressure difference. It's going to vary depending on the manufacturer, which is why we have to refer to it in the design report, as I stated before. But in this case, using the design report, we're going to compare it, and we're going to make sure that pressure difference is ideal, and that there's not too much subcooling and too much superheating. And if there is, then that could suggest that the refrigerant charge is not where it's supposed to be, and we're going to have to add some refrigerant or do whatever there could be a leak additionally. That there's multiple different reasons why the refrigerant charge may not be where it needs to be, but this is essentially to ensure that the unit is operating how it's supposed to be, and so that's one of the checks that we do here. All right, so just like there's a pressure requirement or a pressure change requirement in your refrigerant, there's a certain static pressure, or we call external static pressure, for your AC unit. So if it's operating as intended, the manufacturer will provide external static pressure difference between the return and the supply. And so if that external static pressure is being met, then the airflow within the unit is operating how it's intended to. And so what does that mean? There's airflow going throughout your home, and that's good, right? Because that means your home is being conditioned, your set points are being met, or set point in this case, depending on how many zones you have. And so that's another thing that Energy Star prioritizes in the checklist, and we will take some measurements to do so. And so in addition to doing that, by getting the external static pressure and using the manufacturer data that they provide to us, we can also we can calculate the airflow currently when we do the testing of the unit and see if that's on par with, once again, what the scheduled airflow is. And so we want to make sure it's within plus minus 15% of the design airflow. And if that requirement is met, then things are looking good, and we check that off and move to the next thing. Okay, so air balancing. So another common issue. So if we have sufficient airflow, if the unit is operating, we have a correct pressure difference in the refrigerant, and then we have sufficient airflow, there still may be an additional issue that we run into, and that's when you have unbalanced supply registers and return grills. So this is a very common issue as well. While I would like to note that this is not a requirement, but it's very much beneficial and recommended as well by Energy Star. So we want to make sure that the airflow for each zone throughout the home is being met. So just like there's a system design, a total CFM or a total cubic feet per minute for the unit, we want to ensure that the CFM per zone is being met. So we take a look at the design report, which will list every single zone in the home, and it'll have a required CFM that has to be met. And we will try to get within, ballpark range of within those design airflows to ensure that every room is cool, right? What we don't want is a home where the control zone is usually the largest zone in the home. So let's say the big living room area is really cold, and then all the rooms are really hot. Because then what ends up happening is you could have humidity issues in the rooms because they're too hot, and overall the comfort is not there. So we want to avoid that. And so this is a very simple recommendation, and typically it's pretty simple to fix. What we can do is use dampers to manipulate the airflow throughout the unit, and try to get a little bit more airflow, maybe further down the ducts, to try to get within these design airflows for each zone. And then the fourth test that we also take a look at is the indoor terminal unit. So these are what we call the split system units, the PTAC units. These are very common. These are very common to sometimes aid or help main system. So sometimes you'll see them in a specific room that may be getting hot, maybe because the diffusers are not balanced. That may be an issue. Or maybe it's just an undersized unit, maybe built from a long time ago. It's very old, so it's no longer. We see them in homes that are older, and they'll add one of these to their rooms. But we also see them in new constructions as well. So if we do have them in a new construction, then we do verify to make sure that the zone thermostat is within the zone. So these are typically single zones. So if they're serving one bedroom, for example, then we want the thermostat to be in that bedroom, right? That would make the most sense, as that's where we want the set point to be met. But you would be surprised, maybe that's not the case. Maybe the thermostat is not located within the zone. So we would not want that to be the case. So we definitely check for that. And then the thermostat controls themselves. We want to make sure that if you've ever seen one of these, sometimes they have the temperature located up in the corner, and they'll display the current zone temperature. So we want to make sure that's correct. If that sensor is not working correctly, then the system's not going to operate correctly. So once again, Energy Star is a lot referring to the design report and ensuring that things are operating how they're supposed to be. And so that's what the majority of these checks are going to be. One of the different things I like about this one is that it doesn't just apply to these non-ducted, but also ducted single zone dwelling units. So maybe like a unit ventilator or things that serve a single bedroom. What you'll see is some of them have outdoor air dampers. So we're also going to check if they do, that they're closing when there's no longer a call for any ventilation, or when the fan is off. So we don't want any extra conditioning, extra air coming in that has to be conditioned if the unit is no longer calling for it. And that's just more for efficiency purposes, right? So making sure that the unit is operating correctly, but also as efficient as possible. And so that's why the controls are also a factor. They also play a factor here for the terminal units as well. All right. So that concludes the majority of our, if not the entirety of, I should say, of our material. I know it's been a lot of information. We've gone over some of the requirements for both the single family certification process as well as multifamily, and how they there's a bit of overlap between the two, but there's still different requirements for them. At this time, we want to open it up to the audience and see if there's any questions that you guys may have. We'd be happy to answer them.
Yeah, I see Patrick put a question in here asking if it is similar to LEEDs and NGBS. I can speak to that. They are similar. The main difference is, if you've ever gone through a LEEDs or NGBS project, it's a point system. So you have certain details that if you meet those requirements, you get certain points attributed to them, with a, whatever level being, LEED silver, let's say, is 50 points, and then LEED gold is 100 points, and you get up to that, whatever your desired points or level of certification you are trying to get to, through checking out which options meet your building standards. Energy Star is different in that there is, unless you're doing the prescriptive multifamily path, there's a lot of options for hitting your target score, but then all of that's backed up with these checklists. I think I mentioned our Energy Star, the HERS Rater checklist, the HVAC design checklist, and all that's to say those are all prescriptive items that have to do more with the install and how you are actually building these things. And they are, once again, 100% prescriptive. So you have to do them no matter what. So that's where it's a little different. It's a little bit more stringent on the back end. Patrick also asked a question about, what's the cost? What do you need to do differently to meet Energy Star? And asked a question about our consulting services. So one of the main things, what you need to do to meet Energy Star is going to be extremely dependent on what you're already doing, where you're currently building. There's different requirements for different climate zones. As I mentioned, I think a big indicator for what you might need to be doing differently is knowing which version of IECC you're currently building to. As mentioned, any buildings that are completed starting in 2025 that are single family, they are going to be compared to, at least for a thermal envelope level, to 2021 IECC. So if you're in an area that's already adopted 2021 IECC, as far as insulation requirements and that sort of thing, you're not going to have to change a lot. you're just gonna have to make sure you meet some of those prescriptive requirements we talked about, like grade 1 insulation and drywall gasketing. If you're in a place, and similarly for multifamily, if you're building to 2012 IACC, you're probably not going to have to change a lot from a materials standpoint. And is there, Luis, maybe anything in the from the functional testing agent side of things that builders would have to do differently than they're currently doing when considering their HVAC systems in multifamily buildings?
I would say that it's not. I'd say what Energy Star, the difference is that they have to ensure that the design is taking place on site, which is very different from what. So ASHRAE standards are met using energy modeling or typically different other things. Did it just end? Oh yeah. Oh, it just overran. Oh no, we're still good. And so the ensuring that what's taking place on site, like I said, so we're not just, the design is usually what I've seen is engineers for compliance, they'll design a certain building to meet compliance, given ASHRAE standards, which is one of the paths is, utilizing energy modeling software, and then it kind of ends there. So with Energy Star, it goes past that, in my opinion, or actually, I would say that is the case, because we actually go on site and we're ensuring that is taking place. So it's essentially not just design, but is that actually taking place on site? So